Boom. Hello and welcome back to Calculus 1 section 5.4, working with integrals. So we worked with limits, we worked with derivatives, so let's work with integrals now, right? A whole bunch of formulas that are really, really cool. Let's start with the fact, which we've seen already, that you can interrupt your interval at any point. So the definite integral a to b of some f of x dx can be integral a to c f of x dx plus integral c to b f of x dx. So this is a really cool formula, in my never humble opinion, because it allows us to calculate those areas. Now, without much of a proof here, you can just take a look at any function f of x between a and b and realize that you can get anywhere value c which will be linked. So AC goes here and CB goes there. And when you add them, you get the total area. Do we all see that? So the total area, which is all of this knockoffing, is that one right there. But if I decide to break it into two different areas, then I can compute this area here using this integral and the other area, and then just add them together, and you see that this over here plus this over here is the total of everything. Now, we used this in a previous section where we calculated. Another formula that is really cool is that the integral from a to a of f of x dx is 0. Now, this should be common sense because there's no width. And your dx gets to be a 0, and then times f of x is going to be 0. Because didn't we say that dx is the same as delta x, and delta x was b minus a over n? Well, in your case, a minus a over n, meaning 0. So if dx is exactly 0, not infinitely small, but exactly 0, then you don't have the width. Right? You don't have the width. So area is 0. So that's the cool formula. Another formula, and you are going to use this a lot in Calc 2 and 3, is the formula that allows you to switch the limits. So if you put b on the bottom, then there's the minus in front. So this will pop up in your later coursework if you take more calculus courses. It has to do with substitution and values and so on. So if you need to switch limits, then this minus pops outside and you get to use it. And now, to talk about some of the formulas that are useful. Students usually don't remember these, and you guys go through unnecessary calculations in Calc 2 and 3 anyway. So, if you learn these formulas, then it will shorten your calculations. So the first one is if f of x is even function, then the integral from negative a to a of f of x dx is the same as 2 times integral 0 to a of f of x dx. And if f of x is odd function, then integral from negative a to a of f of x dx is just simply 0. In some higher math courses, this last formula cuts out a page of work. I know. That's not in Calc 2 and 3, but much later. No. Fourier series, yeah, later. Partial differential equations, stuff like that. Now, if you don't remember even and odd functions, even function has the property that f of negative x is the same as f of x. And the odd function, this is all your pre-calc 1, has the property that negative f of negative x is equal to negative f of x. Good examples for the even function would be the cosine x, and for the odd function would be sine x. Now note that I did not draw your standard 0 to 2 pi. I went from negative pi to positive pi, because those are the best that show. Look, when the function is even from negative a on the left side of y-axis to positive a, well, isn't it because it's symmetric? The even functions are always symmetric on the y-axis. So doubling 0 to a makes sense, right? Doubling 0 to a makes sense, because if I'm going for, let's say, this area here, this area here, it's the same as just calculating one side and doubling it. Now remember what I said for odd functions. If you have what I said for functions in general for area, right? If the area goes under the curve, it's a negative area. So now these two areas are the same. The odd function is symmetric in respect to the origin. So when I take the negative area and the positive area here, they add up to 0. Unless I need area under the curve, in which case I'll use the absolute values, and then this doesn't do stuff. So that's my that's the calculation, and we can try a homework example. So problem 18 says integral from negative pi over 2 to pi over 2 of 5 sine theta d theta. And the answer without any calculation is 0. Sine is odd, and because sine is odd on a symmetric interval, guys, it's very important for interval to be symmetric over here, meaning if this is negative 3, then the top has to be positive 3, and so on. So symmetric interval is important. Any of these, problem 22, same thing, negative pi over 4 to pi over 4 of tangent theta d theta. Immediately, 0. Tangent is odd function, and then on a symmetric interval, odd function, symmetric interval. Right, so if you want the graphs, right, there's a graph from here to there, the tangent graph from here to here, and we see that all of these are symmetric and they're all giving you the same areas, and then those areas subtract, you get 0. Now, one problem that I really liked is the integral from negative 2 to 2 of x to the 9 minus 3x to the 5 plus 2x squared minus 10 dx. All right. Again, the most important part is that you have this symmetric interval. Symmetric interval, it's very important. So now when you have a symmetric interval, any of your odd exponents do not count. So you can throw this one and this one in garbage because they are not going to produce any value. So technically, the entire problem now is just this, but these are odd and these are even. So odd is equal to 0, so we can throw them away. And even ones, we know that we don't have to compute. We can, from negative 2, we can compute from 0 to 2, and we only focus on 2x squared minus 10 dx. The rest is not important. So now, 2 times the integral over here is 2x cubed over 3 minus 10x, computed from 0 to 2, and you just need to compute at 2. That's easy. 0 is just going to zero everything out. So this is 2 times 8/16 minus 20. We don't have to worry about 0. So when I plug in 20, or that's a 60, right? 20 is 60 over 3. So that's 44, 88, negative 88 over 3. So the value of the integral is negative 88 over 3, and we haven't even used and calculated half of it because those ones were odd. And we know from before that we can split this into 2 integrals. Well, as soon as you split into 2 integrals, the first integral is equal to 0 because it only contains odd powers, and the other integral is even, so just calculate that. In time, you learn which ones to ignore, which ones no. I mean, if you want this. Again, it's kind of dangerous because you invest a lot of time and effort in memorizing even odd and reviewing all of that, and then you don't do it on the symmetric interval and it's wrong, right? This is only for symmetric interval, right? And, it's not, it's not too frequent, okay, to have a symmetric interval. So, again, these formulas are something that pops up. All right, the last part before we leave, what do we have? Ooh, we have a lot of time. Mean value theorem for integrals. Still the same lecture. So you had your mean value theorem for derivatives. The f prime of c is equal to f of b minus f of a divided by b minus a. We said that that was when the average is equal to instantaneous, and you were able to calculate the value c at which this thing was happening. Now you have a theorem which says let f be continuous on the interval a to b, there exists a point c such that. So let f of x be continuous on AB there exists a point C in AB such that f of c is equal to the f bar, I'll explain that, 1 over b minus a integral a to b of f of x dx. So this is your definition, I mean the theorem, the mean value theorem. This over here is called the average value. Some of my projects, right, because I told you I have problems with rotation and so on. So some of one of the problems for the project is to calculate the average rainfall in the area. So you can calculate, you can actually go online and collect the data of how much rain you have. You can create some kind of function because you can plot that data over time in Excel, do the best curve fit through that, whatever it comes out to be, and then you can run that in the, so for the project you are given the formula of whatever equation is given there, and then you have the months in a year, right? So January is 1 and February is 2 and so on. So now I'm asking what is the average rainfall in month of October, and you go, okay, so that's 10 to 11, right? Because that's the month of October. That's 11, it switches into November, or yeah, 1, 2, 3. Yeah. So you have 0 to 1 is January. Yeah, 0 to 1 is January, so 10 to 11 is November, and then 11 to 12 is December. Yeah, whatever. But you get the idea. I can calculate the average rainfall for three months, right? If I go 5 to 8, right? With the limits, because the limits would contain time, and the rainfall function goes inside the interval. So I can calculate the average if I use this formula. If I don't have this piece in front, if I only use the integral, that's going to calculate the amount of rain that fell in 3 months, right? The amount of rain that fell in 3 months if I have just the integral. But if I put 1 over b minus a, it is going to calculate the average rainfall across those 3 months. If you want a single month, then you just go 5 to 6. 5 to 6 would be June, right? So average value. So let's take a look at, they have average elevation, average distance of the parabola, average velocity, average height of the wave, like that one. Physics. Waves. Problem 38. Waves. The surface of the water wave is described by y equals 5, 1 plus cosine x. Well, if you learned your pre-calculus, you know that this 5, when it distributes, the 5 is going to be the amplitude, because it will be 5 cosine x. If you have a 5 cosine x as the amplitude, then the total displacement from the top of the wave to the bottom of the wave is 10 feet. That's a big drop, right? For a water wave. So that's the idea. Now this will also be plus 5, so actually it should look like this: 0 to 10, right? With the middle line at 5. So the graph should look like this. Now you might know or you might not know this, but I'll just leave it over here. So there's your wave. For negative pi to pi, should be using these. Find the average height of the wave. Well, 1 over b minus a integral negative pi to pi 5 1 plus cosine x dx. So now we can kick 5 outside, and we have 2 pi in denominator. Integral negative pi to pi 1 plus cosine x dx. Now you just learned this, so you are not noticing it, but I am trained as soon as I see symmetric interval to look for even and odd functions, because I'm lazy. So I see that the 1 plus cosine, that's even, and I have symmetric interval. Woohoo! That's now going to be 2 times 5 over 2 pi, integral 0 to pi of 1 plus cosine x dx, because it was even. 2's will drop, 5 over pi, and now I have integral of 1 is x, integral of cosine is sine x, computed from 0 to pi. This is 5 over pi, and when I plug in pi, I get pi plus sine pi, and then when I plug in 0, I just get 2 fat zeros. So this is 5 over pi, and then I have pi plus 0 minus 0 minus 0, 5. Now I'm going to go back to my picture up there and to ask, does it make sense to be 5? Of course it does make sense to be 5, right? Because 5 is in the middle. It's the mean value theorem. The mean value between 0 and 10 is 5. So it matches. Because remember, you're calculating the average height. So the average height will be 5. Another one? Going once?
Yes.
There we go. Okay, so problem 40, find C for f of x equals e to the x on interval 0 to 2. Well, f of C is equal to b minus a, no, lies, 1 over b minus a, integral ab f of x dx. So this is 1 over 2 minus 0, integral 0 to 2, e to the x dx. F of c is equal to 1/2, f of c is equal to 1/2 e to the x computed from 0 to 2 dx. And I get to calculate this as 1/2 e squared minus e to the 0, which is 1/2 e squared minus 1. So I have that f of c is equal to 1/2 e squared minus 1. But f of c is e to the c, because f of x is e to the x. So instead of x, remember, I plug in c, I plug in a flower, I plug in whatever, right? So it's equal to 1/2 e squared minus 1. And to get c alone, we ln both sides. And we get c is equal to ln 1/2 e squared minus 1. You can get decimals for this if you want to. No one cares, but you can. Because all of these are numbers, right? So there is our value of c, where the integral has the value. You know what? Why don't we compute this? Just wanna see it on a graph, and then we'll leave. So ln, open parenthesis, 0.5 times, open parenthesis, e squared minus 1 closed. I get approximately equal to 1.16. So if I draw e to the x function, and I am on interval 0 to 2 at about 1.16, would be the mid value for the interval, for the function. Nice. So what's happening next class? U substitution. That's the one lecture that I said if you don't know, don't learn, do yourself a favor, do not sign up for Calc 2. Ever. 90% of your integrals in Calc 2 will have U sub. Just like 90% of your derivatives are chain rule. We will learn that the U sub is the chain rule backwards, which is why is so much in use. So the next class, we will have that, and we will have the review for your upcoming exam, which is on Monday, May 6th. Your quizzes start tomorrow at 6 a.m. You will have 7 quizzes, 7 days. The last quiz will be the day of the exam. Exam 3 again on May 6th. Review for the final, May 7th. Final, May 8th. The project is due, your labs are due, and so technically about 50-something% or 60-something% of your grade is due, right? So, yeah, get busy. If you haven't the whole semester. But